A warm welcome to everyone. Myself, Tanya S. from the Department of Computer Science and Engineering, Artificial Intelligence. I am from Sri Venkateshwara College of Engineering, Bengaluru. So, the subject is data structures and its applications. The topic is optimal binary search trees. First part, the introduction. Optimal binary search trees, also known as OBSTs, are binary trees that are designed to minimize the average search time. So these are commonly used in data structures and algorithms to efficiently search for elements. So the goal of this optimal binary search trees is to arrange the elements in a way that reduces the number of comparisons needed to find a specific element. So the main goal of this is to arrange the elements in a certain way to reduce the number of comparisons which is needed to specify an element. Okay, binary search trees. Binary search trees are the type of data structures that follows a specific ordering property. So it follows a specific ordering property where binary search trees has to be followed. So in binary search trees, the left child of node is always smaller than the node and the right child is always larger. So it provides efficient search, insert, and delete operations, but the average search time may not be optimal in all cases. So the importance of optimal binary search trees are it improves the average search time by reducing the number of comparisons needed. So they are particularly useful when the search frequency of elements is not uniform. So they provide a more balanced distribution of elements resulting in faster search. The next is elements of an optimal binary search trees. So the OBST consists of set of elements and their corresponding search frequencies. Each element has a probability associated with it, representing the likelihood of it being searched. So the goal is to construct a tree that minimizes the weighted average search time, considering both element and probabilities and the tree structure. So the main goal of this optimal binary searches are it construct that minimizes the weighted average search time, considering both element probabilities and the tree structure. Next is dynamic programming approach. The dynamic programming approach is commonly used to construct optimal binary search trees. So it involves breaking down the problems into smaller subproblems and solving them iteratively. The optimal solution is built using the optimal solutions of the subproblem. So the solution is built by the subproblems. So how to solve these dynamic programming problems? The first one is recognize the the dynamic programming problem. Next, identify the variables. Then express the recurrence relation. Then identify the base case. Then decide the iterative or recursive approach to solve the problem. Then add memorization. So this is how the 6 steps to solve dynamic programming problems. So dynamic programming algorithm steps. Calculate the probabilities of each element and store them in a probability matrix. Initialize a cost matrix to store the cost of searching elements. Iterate through different subtree sizes and calculate the cost for each possible subtree. So these are the three main algorithm steps how we can calculate a dynamic programming approach. Example, cost matrix calculation. So using the calculated probabilities, we construct a cost matrix to determine the optimal search time. The cost matrix represents the cost of searching for an element in a subtree. The diagonal elements of the cost matrix represent the cost of individual elements. In cost matrix, mainly it represents the cost of an element which is equally needed to be distributed or needed to be noted. The next example is optimal subtree arrangement. By iteratively updating the cost matrix, we can determine the optimal arrangement of subtrees. The optimal arrangement minimizes the average search time. The cost matrix provides the necessary information to construct the optimal binary search tree. So in this optimal subtree arrangement, so it minimizes the average search time. Next is construction of optimal binary search trees. Using cost matrix, we can construct the optimal binary search tree. Start with the element with the highest probability as the root of the tree. Recursively add elements based on their probability, maintaining the order property of binary search trees. So the construction of optimal binary search trees are mainly needed in this optimal binary search trees, where it uses all this cost matrix, optimal binary search trees, and they see the highest probability as the root of the tree, and they can maintain the order of a property in binary search trees. The next is advantages of optimal binary search trees. Optimal binary search trees provide faster search times compared to regular binary search trees. They are particularly useful in scenarios where search frequencies are non-uniform. So these optimal binary search trees offer an efficient solution to reduce the number of comparisons required for the searching. So these mainly give an efficient solution to reduce number of comparisons required when searching. So they are particularly useful for the scenarios where search frequencies are non-uniform. The next one is limitations of optimal binary search trees. The construction of optimal binary search trees using dynamic programming can be computationally expensive for large data sets. So the assumption that search frequencies remain constant may not hold true in some scenarios. So in optimal binary search trees may not always provide a significant improvement in performance, especially for the uniformly distributed search frequencies. So these three are the main limitations of this binary search trees where we have to be noted down. Next is the real world applications. Optimal binary search trees are widely used in information retrieval systems such as search engines to facilitate faster searching. So they are employed in compilers for efficient symbol table lookups. These OBSTs are also utilized in language modeling for efficient word prediction and correction. The last part is the conclusion. Optimal binary search trees are binary trees designed to minimize the average search time. So they are provided a more balanced distribution of elements, resulting in faster searches. The dynamic programming approach is commonly used to construct OBSTs efficiently. Thank you, one and all. Thank you very much for this wonderful opportunity.